All right, welcome to the second lecture of week 12 in ISTA130, where we're going to talk about traversing dictionaries. So, we've been talking about dictionaries. We are going to keep talking about dictionaries. Okay, so quick recap, dictionaries. So dictionaries are like a list. Dictionary allows you to store multiple values in a single container. However, in a list, we access those values via index number. So, if you want to access like the 0th or, the second element in a list, you use the brackets and 1 for the index 1 for the second element. That should be second nature to you guys at this point. And essentially you can think about the index as the location of an element within that list, right? So it's just like where that element is in the list. If you think about like a list of like a grocery list or something, like the fourth thing in that list, that's how you might refer to it. So it's kind of the same idea. In a dictionary, we access values via keys. So not the order that they're in, not the index, but by keys, because in a dictionary, you store things in there as a key value pair. And you can find the value associated with the key by accessing the dictionary using the key, right? So again, if you think about a dictionary as like an actual real world dictionary, the key is sort of like, when you're looking up a word in a dictionary, you're looking up a key in a dictionary. That's kind of the idea, right? And then the value would be like the definition. Okay, so a visual representation of a dictionary, what it might look like. So over here you have your keys. Here you have a key for dog, cat, snake, and spider. And then each key has a value associated with it, which is why we call them key value pairs, because it's a key and a value paired together. Your value can be pretty much anything you like. It can be mutable, immutable, doesn't really matter. It can be a list, it can be a dictionary within a dictionary. It could be, you name it, it should be fine. Your keys, however, have to be immutable objects, so they cannot be mutable objects. You can't have a list as a dictionary key. You also can only, each dictionary key has to be unique, so you can't have dog twice, because that doesn't make sense, because dog should only be associated with like one value, because these are key value pairs. All right, some code. So more specifically, some code about how to update things in how to update your dictionary, essentially. And there's essentially two different ways, or the way that you update your dictionary will depend on what already exists in your dictionary, right? So we've talked about this before. Essentially, if you want to update a key value pair that already exists, it's essentially the same code that you would use to either update it or create a new one, right? Ish. We'll see what I mean in a second. So what that means is that, so if you essentially do pet dict and then bracket dog close bracket equals something, what that will do is it will update the key value pair dog and whatever value. So it'll essentially erase this value and add whatever value that you attribute to it, right? Which might not be what we want. We want to probably update the existing list and not just kind of erase it and replace it with something new, right? However, if you use the exact same code with a key that doesn't already exist, for example, bird, then if you do, pet dict bird equals whatever the name of your bird might be, then it will create a new key value pair for bird and then whatever the name of that bird is, right? So essentially, some code that essentially allows you to update your dictionary in a way that's appropriate for this kind of situation here, where you want to either update an existing list or create a new key value pair, depending on whether or not that key already exists or not in your dictionary, right? So essentially, that's what this code does. So it's essentially checking if pet type is in PD. So does the key, does this new pet type, this new key already exist in my dictionary PD? And so if this value is true, then what you're doing is you're essentially appending your new pet name to the existing key value pair, right? So for example, if I wanted to add I have a dog and her name is Chewy. If I wanted to add my dog to this list, I would first, this part over here, if pet type in PD, pet type would be dog. And so dog already is in PD. And so this should evaluate to true, right? And so if this is true, then PD pet type, which would be assigned to dog, dot append pet name, which would be Chewy, right? So this is a way that you would essentially update this list, and then you tack on Chewy at the end of this. You would append Chewy onto this existing list, right? If I just did pet dict dog and then Chewy, it would erase this list and just have a list with one single element with it, which is just Chewy in it, right? Which is not what we want, probably. And then here, so if this is true, then it does this. And so if this is false, if, for example, pet type is bird, then this would evaluate to false because bird doesn't already exist in this list, or sorry, doesn't exist in these keys of my dictionary. And so this would evaluate to false, and so it would fall into the else, and then it would essentially do this, which is essentially creating a new key value pair, which would be bird, and then, you know, whatever, Roscoe or whatever you want to call it, right? Yeah, okay. So, and so this might come in handy for some of the assignments and things that we're doing, so just kind of keep that in mind. The way that you update a dictionary sort of depends on whether that key value pair already exists in that dictionary or not, right? Okay. And so the operator in, which we literally just talked about here, pet type in PD, we've talked about it a little bit before. We're going to talk about it. I'm just going to do a quick recap of it right now. The in operator essentially looks for keys, not values, when you're working with dictionaries. If you're doing something in a dictionary, it'll look to see if there's something is in the keys of that dictionary, right? So if we have a dictionary over here for cheeses with these three key value pairs for Manchego, Spain, Leiden, Netherlands, and Cabrales, Spain, then what we can do is if we do Cabrales and cheeses, Cabrales is what we're checking to see if it's in cheeses. And as I just said, the operator in looks at the keys, not the values. So the keys are over here, Manchego, Leiden, Cabrales. So Cabrales is within the keys of the dictionary, so that will return to true, right? That'll evaluate to true. If we look for Spain in cheeses, that will evaluate to false because none of the keys are equal to Spain, right? There's a value equal to Spain, but no key, and so this will return to false. Same thing if I do easy cheese in cheeses, so there is no key called easy cheese, so that is false. And if I throw in a not in front of it, then I'll basically flip my false to true. So easy cheese not in cheeses, that is true, right? So easy cheese is not in my keys for my cheeses dictionary. So that evaluates to true. All right, the function length applied to dictionaries. So len, the function len for length, essentially tells you the number of key value pairs, right? So it'll count the number of key value pairs you have in your dictionary. So if we're looking at this dictionary over here, len of cheeses would be 3, right? In this dictionary over here, there's actually 4 key value pairs: Leiden, Netherlands, Manchego, Spain, Wesdale, England, Cabrales, and Spain, so 4 key value pairs, and so length of cheeses here would be 4. We can access, oh yeah, so we can add a new key value pair for cheddar and England. And again, you'll notice the values can have the same value, but the keys have to be different. So cheddar doesn't already exist, so that's fine. And if now we look at our dictionary, the length will be 5 because we just added a 5th key value pair, which is cheddar England, right? Okay. So right, methods that you can use with dictionaries. So these are going to be pretty handy. So up until now, most of the functions that you apply to dictionaries, like length, for example, they mostly just work on the keys, right? On the keys of the key value pairs. If you want to access the values, you can use the method values, which will return the values of your dictionary, right? So here, if we do Spain in cheeses.values, so applying the method values to the dictionary cheeses, this will evaluate to Spain, Netherlands, and Spain. Right, and so so Spain is in the values of cheeses, and so that should return true. If you look for Cabrales in the values of cheeses, so again, this will evaluate to Spain, Netherlands, and Spain. And so within those 3 different strings, is Cabrales there? That is not true. It's not there, so that will return to false, right? Okay. Right. So when you do cheeses values on its own, it actually, so this evaluates to, and I was pretty vague about it, cheese's values essentially evaluates to a collection of these three strings, right? If you looked at what type of object this would be like a specific type of object, which is a dictionary values object, which is its own kind of thing, right? However, it can be useful sometimes if you want to translate this into a list, into something that kind of is more easily managed and you can do other things with. You can use the list function to essentially convert the values into a list. And so here, if we again have this this dictionary over here with these three key value pairs, and if we wanted to create a list with the three values of the dictionary, we could do cheese's values over here, and then this will evaluate to the dictionary values of these three strings, and then we can put those three into a list, and then that will essentially evaluate to a list with those three strings in it, right? So that's something that probably will come in handy a fair bit. So just like the values method, there's a keys method where you can access the keys of a dictionary. So if you do cheeses.keys, and you can put that into a list as well, you can essentially create a list with the keys of your dictionary. So keys essentially works just like values, except it returns the keys instead of the values, right? However, we basically don't really ever need to do that, and we don't really need the keys method in general, because you can sort of, if you just so this is what we had above, right? So we essentially had a dictionary.keys into a list, and it creates a list with the two keys of the dictionary. If you just kind of skip all that, you just do list of a dictionary, it'll automatically do that for you. It assumes that when you're trying to create a list from a dictionary, that you're trying to create a list from the keys of that dictionary. So essentially the .keys here doesn't really do anything. By default, it kind of does that anyway. So it's not super necessary to use the keys method. The method pop, which works, which we looked at and we learned about for lists, it essentially works the same for dictionaries, except instead of popping the last element of the list, it pop the last key value pair of a dictionary, right? So if we have this dictionary over here with two key value pairs, we print cheeses, there's two key value pairs, so that's so far so good. And if we essentially do cheeses.pop laden, we can essentially we can tell it which key value pair to pop. And so here, pop cheeses.pop laden. Essentially here we're removing the Leiden Netherlands key value pair. And so what's going to be left in cheeses is going to be Manchego and Spain. And because we stored this, there's an assignment operator here. We assigned whatever this returns into popped cheese. Just like a list, this will evaluate to whatever you're removing from your dictionary, right? And so here we're removing the Leiden Netherlands key value pair, and here instead of it won't store the key value pair, it'll actually just store the value that's being popped. Right. So here, this bit of code evaluates to the value of the key value pair Leiden Netherlands. Right. And so pop cheese will be a string, the string Netherlands. Right. Okay. So all this, I mean, it's slightly different because it's a dictionary, but essentially this is stuff that we've already seen before. It works more or less like the way that it did for lists. So this should be fairly straightforward for all of you. Right, creating copies of dictionaries, right? So I think last week or maybe the week before we talked about aliases and copying objects and having objects refer, or having different variables refer to the same object, or having them be two separate objects in the computer's memory. And so if you want to create a real copy of a dictionary, this is essentially how you do it. You can essentially use the dict on a dictionary, and that will by default create a copy of that dictionary, right? So here essentially we're saying dict of a dictionary, the dictionary cheeses, which is defined over here, and then we're storing that into variable cheeses copy. And so this cheeses copy is going to be a distinct copy. So if you change one key value pair in cheeses, so if you're changing Manchego to yummiest in cheeses, if we're printing that'll, the value of Manchego is yummiest. In cheese's copy, that value pair is not affected because they are two distinct objects. They don't refer to the same dictionary, right? So this is one way that you can create a copy of a dictionary just using the dictionary function. The copy method works on dictionaries as well, so you could also do that. Yeah, so you can use the copy method instead. Either work. I find this a little bit less confusing, but whatever works for you. The method clear. The method clear essentially removes all key value pairs from a dictionary. So essentially, if you have stuff in your dictionary over here, you can use the clear method, so cheeses.clear, to remove all the key value pairs, and then you end up with an empty dictionary, right? So again, similar to lists, all this is fairly just kind of more of the same, just slightly different because it's a dictionary, not a list, right? Right, using for loops on a dictionary. So a for loop will iterate over the keys in a dictionary. So what that means is that if we have a dictionary over here with 3 key value pairs, and then if we do for cheese in cheeses, essentially what will happen is it will store in the variable cheese the keys of the dictionary cheeses, right? And so what you see here, and so if you run this, you'd actually get, so this is from an older version of Python where the dictionaries weren't sorted. They are now sorted, so this will actually come out in a different order. But that's okay. It'll probably be, I think, Manchego, Leiden, and Cabrales in the proper order. But essentially, the idea here is that you're essentially the variable cheese here will be assigned the first key in the dictionary, then the second key, then the third key in the dictionary, and that's what we're printing down here, right? Okay. You can also you can use a for loop to print the values, and here you can basically just, if you just index the dictionary using cheese, which is going to be a variable that contains each key of the dictionary one at a time at each iteration of the loop. So you're essentially saying cheeses in the first iteration, cheeses Manchego, cheeses Leiden, cheeses Cabrales, and then it'll output the values for each of those keys, right? Again, the order here is not right because this is from an old slides where it was a previous version of Python, but hopefully you get the idea. Okay, so what you can do also, if you want to print out everything in the dictionary, you can do that like this, where you can essentially concatenate these things together all into one long string. So over here, you're creating your dictionary, you're saying print some yummy cheeses, and then you're essentially creating a variable called key in my dictionary cheeses, and so key will take on the keys of my dictionary one at a time at each iteration. And so here, if you're printing key plus an arrow plus cheeses key, essentially what you're saying is print the key and then an arrow and then the value for that same key, right? And so in the first iteration of the loop, key will have the value Manchego, and so you're saying key, so Manchego, arrow, Spain, because that's the value of cheeses Manchego, right? And again, this is what you have down here. Again, not in the correct order, but you get it at this point, hopefully. Okay. Right, and because a dictionary is mutable, you can do things like this, where you can essentially you can update the values in your dictionary, and so you do this like this. So again, this is the same thing we've done with lists. Just the way that we index the dictionaries is different because here we're not using numbers to index the position, but we're using the string of the key of the dictionary, right? So essentially what we're saying here is, for key in cheeses, key will take on the value of the keys one at a time. And so you're saying cheese for the first key equals cheese of the first key, and then upper, so you're saying uppercase of whatever's in there right now, right? And here you're referring essentially to the value for that key, and then you're taking that value and making it uppercase, and then storing that into wherever it was before, right? So in the first iteration of that loop, what you'll be doing is you'll say the first iteration key will take on the value Manchego. So you're saying cheeses Manchego equals cheeses Manchego upper. And so cheeses Manchego upper So cheeses manchego evaluates to Spain. Cheeses manchego upper evaluates to Spain in all caps, and then you're assigning Spain in all caps to cheeses manchego, which is where the Spain used to be, right? And so this Spain with no upper caps or just the first letter capitalized will be all caps at that point. And then you do that one after the other. And so at the end of it, when your loop has fully iterated, all three values will be capitalized, right? Okay. So back to lists. So a couple of methods that I want to talk about quickly are the sort and sorted. The sort method and the sorted function. That's right. Which operate slightly differently, do something similar but operate slightly differently. So if you create a list and you do list.sort, your list will then be sorted, right? So the .sort method sorts your list. You don't need to reassign anything. By applying that method onto that list, you're essentially saying change this list, right? And so your list is just straight up changed by using the sort method. The sorted function. So here if we create the same list and then we do sorted list, this evaluates to a sorted list, but it's not actually stored anywhere, right? So this will just evaluate to something, and if you want to store it somewhere, then you actually have to assign it into a new list, and so list 2. So list 2 will be sorted because you've assigned it to a new list, and then list original will still be the way that it was when we started, right? So again, the method sort here, fundamentally it automatically changes your list. The sorted function doesn't change your list, but it returns a sorted list. All right. All right, traversing dictionaries use the sorted, not sort. So that's why we're talking about the sorted versus sort. Is because when you're traversing dictionaries and you want to traverse a sorted dictionary, you should use sorted and not sort. And we'll talk about why in a second. Obviously, this was more relevant when Python didn't take into account the order of a dictionary. Since it now does, this is less useful, but it can still be useful to be able to traverse a sorted dictionary. So yeah. So like I was saying, the way that you would do that is, so if you have your dictionary over here, and then with 3 key value pairs, and then you could traverse that dictionary, a sorted version of that dictionary, by doing for key in sorted a dict, right, which is my dictionary. And the reason we can do that is because this sorted a dict returns, so this evaluates to a sorted dictionary, right? So this bit of code evaluates to a sorted dictionary, a sorted version of a dict, right? And so when you're doing for, essentially this, it's going to assign the key will take on, in the first iteration, key will take on the value of the first key in the sorted version of a dict. And so if you sort it, it's sorted essentially by, I think by ASCII value. But so if they're all strings, it'll sort them by alphabetical order. And so, right, and so sorted version of this would be, dog would be the first value because that is the, I think also in ascending order, if I remember correctly. Yeah, it does. Okay. And so key, because this refers to a sorted version of a dict, the first key in sorted a dict is going to be dog. And so key in the first iteration will take on the value of dog. And so it'll print dog and then the value for dog, which is cat, right? And so it'll print out essentially dog, cat, frog, fly, lion, zebra. So a sorted version of a dict, right? If we did this instead, if we did list a dict.sort, if we did for key in dict.sort, that would not work. And so the reason why that wouldn't work is because so a dict.sort or list a dict.sort, either which way, yeah. If you did that, this actually does not evaluate to a sorted list. What this evaluates to, the sort method what using the sort method on the list does, what it evaluates to, is actually none. It changes the values within list, but this bit of code evaluates to none. So that's kind of an important distinction. When you're applying a function to a dict, like sorted, it evaluates to whatever you're doing, in this case, a sorted version of that dictionary. If you apply the method sort, it evaluates to none. It changes your list, but it evaluates to none. So hopefully that kind of makes sense. And so if you're trying to traverse something that evaluates to none, then essentially key will take on the value of none. It will iterate once, and then that'll be the end of it, right? So that's not what we want. And so if you're trying to traverse a sorted dictionary, use the sorted function, not the sort method. Okay. So I think I talked about this in the last lecture a little bit, sort of thinking about what should be keys and what should be values, right? So currently in our cheeses dictionary, we have cheeses as types of cheeses as the key, and the country as the value, right? And that can make sense. Like, depending on what you want to do with it, that can make sense, right? But say that we want to print out a list of all the cheeses from, say, England, right? Or from Spain. We could do it, like, it's doable, but it's a little bit awkward and a little bit unwieldy when really it doesn't need to be, right? What you could do instead is you could like flip it, and you could assign the country as the key, and then create a list for each cheese that comes from that country, right? Which would make sense in that case. So both dictionaries make sense. It just depends on kind of what you're going to do with it. And so when you're creating a dictionary, what you probably want to do is think about, what am I going to do with it? What's going to be my key? What's going to be my value, right? Yeah. So just kind of some food for thought there. All right, so this is a quick recap, a quick overview of all the methods and everything that we talked about for dictionaries so far. Creating a new dictionary with either just the curly brackets or the dict function, accessing the keys and the values of a dictionary, using the in operator to test if a key is in a dictionary, accessing values within a dictionary using the key, popping key value pairs using the pop method. And here, one important distinction here between this and the list version of pop is you need to have an argument. If you just pop with no argument, it'll throw you an error because essentially you need to tell it which key value pair to remove, right? It's not going to necessarily remove the last one. I think that's a holdover from when dictionaries were not sorted. You would never know which one was the last one. But anyway, either way, you need to put a key as the argument. The len function to return the number of keys in a dictionary, or key value pairs, really. Traversing a dictionary using the keys, emptying a dictionary using the clear method, and then creating copies of a dictionary. So this is kind of everything we've talked about with dictionaries so far. So yeah, so this is what we've already talked about before, essentially traversing a sorted dictionary. I don't know how much this is actually still relevant. Python coders often use a syntax, sure. Again, it depends on whether you need your dictionary to be sorted or not at this point. Anyway, yeah, so you can't always do that. If the keys aren't comparable to each other, for example, if you have a string and an int, that gets a little bit tricky. So that's not always possible. But in most real life situations, that'll work fine using the sorted adict. Generally, so it says do not do this, and it's a really bad idea, which is generally true. Essentially, do not alter mutable objects while iterating over them. So if you're iterating through something, you should probably not be changing them as you're iterating through them. That's not always true. Generally, you don't want to do that just because it might do some things that you're not expecting, and then by then your mutable object is like messed with, and so you're kind of like stuck. Generally, what you do is you create a copy of that thing, and then, you either create a copy and then mess with it, or you would just essentially like rebuild a new copy of it as you're iterating through, instead of changing the one that already exists. I think we're going to talk about that more next week, so don't worry too much about that. But generally, the idea is in general, you don't want to change mutable objects while you're iterating through them. ish. All right, and that's all for this week, or at least the lectures. I will see you all in the coding tutorials, which you should be heading to next.